Hello, everyone. We have today another Leetcode premium question. This is parallel courses, and it's actually similar to a different Leetcode question. I hope you guys have done this one before. This is called course schedule, right? So, I'm going to read the question. Basically, you are given an integer n that indicates that there are n number of courses labeled from 1 to n, and you are also given an array of relations, right? So you are given basically a matrix where the matrix elements, right, have prev course to next course, basically, right? That's the relationship between two different courses. So that's kind of like an edge in your graph, and it's a directional edge, right? So you're from the previous, you're going to the next course, so it's directional. It's not bi-directional. And basically the question is asking you, right, in one semester, I can take as many courses as I am, as long as you've previously taken the prerequisites, right? So return the minimum number of semesters you need to take all the courses. So basically, the question is asking you to like the question is asking for the minimum number of semesters you have to take the courses, and you can only take the courses when you take the prerequisites before them. So the best way to solve this question, right, is to go through the edges, right? First doing the elements with no prerequisites, right? So, like for example, you see this graph, you have node 1 to 3, right? And then we have 2 to 3, right? 1 and 3, so 1 and 2, these nodes have no prerequisites. So I could probably take them first, right? And after taking them in my first semester, right, then I come in, and then in the next semester, I've taken all these prerequisites. So I'm finally to take this course. So then it will be what, in two different levels, right? So in two different semesters, right? Um, Also we could have a cycle, right? So a cycle is like where you depend, everyone depends on another, right? So one depends on two depends on three, and three depends on one. So it's a cycle, right? So here the person is not able to take any course because every course is a prerequisite of another course, right? And that is not valid. So we also want to return what, -1. And how are we going to solve this question? Well, basically, we're going to use Khan's topological sorting. This is why I said using doing course schedule might be more helpful, or doing alien dictionary might be a bit more helpful before doing this problem. But basically, with topological sorting, right, we have elements with in degrees, right? So one, for example, will have an in degree of 0, right? Because there's no one pointing to it. In degree just means who is pointing to you. Three will have in degrees of 2, and the element node 2 will have an in degree of 0 also, right? So the elements with 0 in degrees will be the first ones that we process. And once we are done processing them, right, we reduce basically we'll reduce the in degrees for what was depending on them, or for their neighbors, basically. So if I take out one, right, so then there's only one element that's depending on what that 3 depends on, right, which is what 2. And if I take 2 out also, right, then 3 has what, no in degrees, no one is pointing to 2. So two's in degrees now becomes 0. We process it, and then I keep a count of basically that. So basically we want to keep our semesters, right? The count of our semesters in levels, right? For the levels of elements that we process at a time, right? We're going to use a simple BFS, and not much talk. Let's just get into it. So basically, I want to have an adjacency list first, right? It's going to be a list of integers, and it's a graph, and then it's an array list, basically, of n. I think it's n plus 1, right? Because we're going to start with, actually, I could, let me make it n, right? N, because we have from, basically it's what, from n, so 1 to n, right? So I can deal with it. And for every node we meet, we just subtract by 1, so it fits with the 0 indexing, right? Cool. So for in k is equals to 0, and k is less than n, and k plus plus, blah 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 blah, right? For each um next in the adjacency list, right? Set first an empty array list, and to that I will add the neighbors. As you know, it goes. So for let's call it edge in relations, right? Our source is what's the first element in our edge, right? And then our destination is V, right? And that is also the second element, basically, right? So the adjacency of U to that will add what's V, right? We are building the graph, and also want to keep the in degrees, and I think that is something I had to have prepared outside, right? An array to keep what the in degrees. So I'll say in degrees equal to n. And note that I was doing it by zero indexing, right? So we have to decrease each node by what -1 basically, right? So that I have the appropriate node value. Um, so yeah, and then I'll say that the in degrees of v, right? Because v is who's being pointed to. I just increase is in degrees by what 1, right? So when that is done, what we want to do is now do our processing with our cans, topological substitute cans. Um, we have a queue and a linked list, and with cans, basically we first add the elements. If it's bidirectional, we add the elements with an integer of 1, but this one is unidirectional, right? So the rows with zero indicators or no dependencies are first we're going to add to our queue, right? So for in case less 0, case less than n, and key plus plus, right? Right. For them, we want to process um excuse me, we want to say that if the in degrees is of k, whatever the node is equal to 0, right? Then we add that node to listen q, and then from there we want to keep a variable to see if we've touched all the nodes. If you're able to touch all the nodes, it means there was no cycle with constant topological sorting, right? Because we are removing the elements with the um, 0 in degrees. But if you have a cycle, for example, the in degrees of every element will never be this 0. So we wouldn't be able to process every single element. Right? So we're gonna keep um, a variable for the number of nodes that we process, which is what's initially going to be 0, and also for the number of semesters that we're going to use, right? So initially we're going to keep it at 0, and then now we're going to go through our queue. Let's get rid of this here. Come on. Okay, cool. Right. So our queue is now empty. Um, we want to pull. So our current is going to be queue.pull, right? Pulling whichever node we have in first. And once you pull a node, you want to go all its neighbors, right? And reduce the in degrees by at least by 1, right? So we'll do for its neighbor in what basically the adjacency list of current, right? So that's how we get to the neighbors of current. Now in degrees of the neighbor, right? Minus. We're going to reduce it by 1, and after that we want to check, right, if the in degrees of the neighbor, if that is equal to 0 also, right, then it's fit for processing, right? So we add it to sorry, excuse me, we add it to q, right? So q dot add what's neighbor. Cool. Okay, so once all this is done, we also wanted to keep what um while all this is done, right? Okay, I think there is a problem with my code just a bit, and it's because we want to be processing in levels in terms of the semesters, right? The semesters initially, let's say we have like a certain number of courses in our queue, and all of them have initially uh, in degrees of 0, right? Now, when we process their neighbors, right, the neighbors will be added, but it will be in a different level. So that different level should be in another semester that we are going to deal with, right? So initially, what we want to do with our while loop is, let me get rid of everything here. And initially with our while loop, what we want to do is now while the queue is not empty, we want to keep something called semester. Sorry, size, right? I want to keep the size of the queue. And for the elements in our queue, or at least for that number in our queue, we go through, we process all of them, and then their children who get added or their neighbors who get added, right, will be in a different level, if you get what I mean, right? So for them, with that, and then I'll have my different while loop, which is saying that while size is minus minus, so that when we decrease the size after every element that we pull. Now, while that is greater than zero, right? So then we are free to pull. So then we pull the current, which is what Q of pull, and then as I was saying, for its neighbors, we process and reduce the basically the increase by what one, because we've removed an element, right? So whenever we deal with one node, also we want to increase our number of nodes that we process, right? So process plus plus, right? So current we pull, we increase our process, we count for the neighbors basically, and basically in degrees of neighbor minus minus, right? And then we check what if in degrees of the neighbor is equal to what zero. If it is, then we add to our queue, basically. Right, so we add neighbor to our queue. So cool, we add neighbor to our queue, and once this level is processed, we increase semesters by what one. I think it's called semesters by one. And when our whole while loop terminates, like what we're going to check is if we've gone through every single node, right? So if process is equal to n, basically, right? I want to check if it's equal to n. So here, for example, in the first case, n is 3, right? If we process all the 3 nodes, which is not possible because we have a cycle here, right? If it's not equal to 3, sorry, it's not equal to 3, if our process is not equal to 3, right? Then we want to return what's -1. Else, if it is, right, then we want to return what a number of semesters, right? So that's that. And we have a result and a few oh, guys, no bugs, guys. Okay, so it seems that there's maybe something that I missed. So let me go through and just check for a second. I think I've seen that issue, and there's a small issue here, basically. And I had to even check like my original code, but basically it's just here, right? So if the process, right, is not equal to n, right, like we've not processed all the nodes, right, that is when we return -1. This is what is keeping us behind, basically. But like the process to solve the problem, right, was fine. Right, what we did was count the broadcast sorting. If you've not seen that, please check out my video on course schedule, right? And then I, want to talk about the runtime basically, right? But we are touching. So basically, for this one, we're going to touch every edge once at the most, right? It's an off and solution, beating 93% of solutions with Java, right? Users with Java. I hope you guys, like the video and got more out of it. I'll see you guys on the next one. Peace.